Hello, I welcome you all to this another interesting screencast. The problem reads, determine the components of reaction at A and B. So say B, A, B. So say A, B, and where else? So say C and D. Okay, all right. This problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. So to start with, let's draw the free body diagram at D. That's a three force member, so we expect two reaction forces there. We have a dy and we have a dx. Then we have a roller at B. We only have one reaction, which is a by. Then at A, we have a hinge. We expect two reaction forces. We have A, Y, and AX. Okay, so we cannot solve this the way it is because we have more reaction forces than the available equations of equilibrium, and therefore we need to dismantle it or disassemble it. So let's do that. Let's draw this very quickly. So let's have one member here. This is A, B, C. And let's also have another one there, which is member member CD. Great. Let's label it quickly. So we said this point is A. So we have AY and we have AX. Then we have a moment at this support, which is equal to 800 Newton meters. Then we have a reaction force here, which is by. This is at B. And then we have, let me reduce this to this so that it matches. All right, not like that. There is some space remaining. I'll leave it like that. And then here, when you look at this particular system, I will draw it here first. It's free to move in this direction. Look at this, in this direction, you see. Okay, it can move here in this direction, in this slot. All right, therefore we only have the reaction force in this direction like this. Okay, is that fine? We have the reaction force in this direction like this. All right, okay. So let's indicate that. We can indicate here we're going to have a reaction force like this, perpendicular to the longitudinal length of that slot. Let's call it C. So if we have it like that, then we expect the opposite here. We expect the opposite here. Let me draw it. It's just going to come down also, but just different signs. I mean different, is going to be in the opposite direction like that. Okay, and this C. Okay, this point is C. All right, I know you are talking about the slope. To say what is the slope, the slope we know because I'll indicate the slope. Just give me just few seconds. We have dy, we have dx. This slope we've been told is 45. When you have 45, things even become more easy. All right, okay, so let's call this 45. Let me put C here. I think I put C here. All right, let me remove it there so that I have space for indicating the angle. Let's call this 45. Right, up to there like so. And then what else? Then we have a load here. We have a load, applied load at the mid span of this member, and this is a 600 newtons. This is a 600 newtons. So this point is C, this point is D, and then the dimensions, let's indicate the dimensions. We are going to have dimensions like so. We have this, this, okay, all right, and then we have this like so. Okay, so this is equal to 2 meters, this is equal to 2 meters, this is equal to 1.5, and this is equal to 1.5. Great. So if we know that is 45, so we expect a component in that direction that we're going to call C cos 45, and then we'll have another component in that direction that we're going to call C sine 45. But we know that sine 45 and cos 45 are the same, right? Great. And so is also here. If we have these, then we expect components in this direction. We are going to have this one here is our C. Can it fit there? This is going to be our C sine 45, and then we'll have this one here is our C cos 45. Okay, great. So I think we have everything that we need. We have more unknowns in member ABC. We have BY and C, all right, and AY. So we are better off starting with the member with few unknowns, which is member CD. Okay, so let's start with member CD. All right, CD. Okay, so there we go. We start with CD. Let me start here. We are starting with member CD. So let's take moments about point D. So say summation of moments about point D equal to 0, and clockwise being our reference. What do we have? What do we have? Let me move this maybe somewhere here. What do we have? We have that is anti-clockwise, so positive moment 600 by 600 by 1.5. okay, then minus, I just indicated these components for the sake of indicating them, but when it comes to taking moments, we can use C directly, right? Because C is already perpendicular to the lever arm. So there it will be minus C, okay, C, okay, by 3, okay, equal to 0. And therefore our C is just going to be equal to, where is my calculator? So 600 by 1.5 divided by 3. This gives us C equal to 300 newtons, right? Okay. So we found what C is. Let's move on to the other part here. Okay, we can find dy and dx. So we'll say summation of forces in the y equal to 0, going up in our reference. we need now those components there. So we'll say dy plus cy, our cy is just c cos 45. Then this is also going to have components. Okay, we know that all the sides are 45. This is 45 here, and so is the other side. So let's say we are going to have components also here. We'll have component, this component here is going to be equal to 600 cos 45, and then we'll have this other one here, which is 600 sine 45, right? So this will be minus 600 cos 45, okay, equal to 0. Therefore, our dy is equal to, mind you, we've already found what c is, so just replace c there, replace it there, okay, and then our dy is equal to, so we have a 300 cos 45 minus 600 cos 45, and then we have dy equal to 212.13 newtons, right? 300 cos 45 minus 600 cos 45, that's 212.13 newtons. And then we have summation of forces in the x direction equal to 0. What do we have? We have c sine 45, okay, and then minus 600 sine 45, and then we have what do we have? And then plus dx equal to 0. Therefore, our dx is just going to be equal to, at this stage we've already found what cy is, so let's get the portion of c, we bring it where we need to bring it. We can bring it here, we plug it there, so that we find, okay, let me move it to the other side maybe. So let's borrow this c there, we bring it like this, like that. So we plug it there, and once we do, then we'll find that we have a 300 sine 45 minus 600 sine 45. Okay, so this we expect it to be the same, okay, because of the angle. Great. 212.13 newtons. Great. So found those components. So we need to now move on to other part. We need to move on. Let me just move this a little bit. I move it maybe there, so that I have some space there. Okay, so that I have some space. Let me just create a boundary here. So let me replace these values here. dy is a 212.13, dx is a 212.13, and then c, we've been told, not told, we calculated it, we have not been told. C, we found C to be equal to 300, okay, and then the same C here is equal to 300, okay, this C here is equal to 300. All right, we now let's find now dy and ay. So let's take moments let's say moments about A. So let's go to this point here. We say we are dealing with member A, B, C. Okay. So say summation of moments about point A equal to 0 anti-clockwise. In our reference, what do we have? We have a positive moment by by 2 plus a positive applied couple moment at A. This is negative, right? This is a negative, it's a clockwise one, so minus 800. And then we have another negative moment from C, cos 45 times the lever arm, which is a 4, equal to 0. Therefore, by is just going to be equal to, mind you, we already know what C is. C here is equal to 300. Alright, so we know that C is equal to 300. Okay, so once we plug in all those values, we have minus 800 minus 300 cos 45 by 4, 300 by 4 cos 45, then divided by 2. And by becomes equal to 824.26 newtons. Let me check it again. That's 4 minus 4 by 300 cos 45 minus 800 divided by 2, 824.26. That's our by. Great. And then we have summation of forces. Summation of forces. Summation of forces in the summation of forces in the y direction equal to 0. What do we want to find there? We want to find AY. So we have AY plus BY minus C cos 45, okay, equal to 0. Therefore, we know what 300 is. What C is. C is equal to 300. And then B, we already found what B is. B, let's just borrow the B there. We already know what B is. We calculated it, so we just replace it there. So once we do so, we'll find that our AY is just going to be equal to, we have 824.26 minus 300 cos 45. Then our AY is just going to be equal to minus 612.113 newtons. Okay, so 824.26 minus 300 cos 45, 612.13. Alright, and then finally we have summation of forces in the x direction equal to 0. Okay, what do we have? We have AX minus C sine 45 equal to 0. Like we've said, C is equal to 300. So with this, we just say AX therefore is going to be equal to 300 sine 45 gives us a 212. So this is 212.13 newtons. Great. So let's replace these values. We have AY equal to 612. The sign changes here. The sign is going to change. This one here, ay is negative, so sign changes is going to be like this, and it is 612.13. by, let's elongate it a little bit. We bring it up to there. We say by, what did we find? By is equal to 824.26. Okay, and ax, what did we find? Ax is equal to 212.13. Great. So found everything, right? Let's just replace here. We have dy equal to 212. 212. Let me just check one thing here. Okay, so we have dy equal to 212.13. Okay, and dy and then dx is also equal to 212.13, and then by is equal to 824.26, and then ay, the sign changes, that's what we said. This one is equal to 612.13, and ax is equal to 212.13. Let's check whether this equilibrate. We know that this will give us equal to cy, this one will give us a 212.13. This one is also equal to 212.13. So this and this 612.13 plus 212.13, 824.26. Okay, great. In the y they equilibrate. In the x they also equilibrate, and I'm sure also the moments. And then let's go to this other member here. We know also to say this one is equal to 212.13, and so is this one 212.13. So in the y we have these two, and then this one here is equal to 600 sine 45, gives us a 424.26. And then this one here, let me just bring it closer there, gives us also the same value. We bring it there like so. So this is also equal to 424.26. Okay, so in the y direction we have 212 and 212 by 3 by 2, 424. Yes, in the y it does. And in the x we have two of them, it does. Great. So let's outline our solutions. We have by there. Okay, we have ay there. Okay, we have ax there. Okay, we have c. Okay, we have dy. Okay, and then we have dx. Great. I think this is really about it, and I hope the video was helpful. If it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.